right, Nighthawks, Unit 4, Lesson 13. Our objective in this lesson is to analyze and classify triangles based on side length, angle measure, or both. So our first one, you have these. They are your templates for Lesson 13. So A in your templates is an equilateral triangle. All sides of this triangle are identical. I can check that using a straight edge. So each of my sides is 13 centimeters. This side is 13, and this side is 13, okay? All angles measure the exact same. So if I put my protractor on, I'm gonna check my measurement. So if I'm looking at my measurement, that's 60 degrees, 60 degrees, and 60 degrees. All are acute angles. 60 degrees is less than 90 degrees. And it has one line of symmetry. So the dotted line shows the line of symmetry. The second set of triangles are what we call isosceles triangles. They have two sides that are the same length. A right angle can be one of the angles, and then you could have two acute angles, or you might have two acute and one obtuse, okay? Or all three might be acute, but they are not going to measure the same. So in your templates, E, F, and B are isosceles triangles. So I could measure them. So this is 19 or almost 20 centimeters long, and these sides are both 11. Okay, so I check to make sure that two sides are equal, and they are 11. And then I would go in and I would measure the angles, knowing that this is 30 degrees. So this side should not be 30 degrees. Nope, it's obtuse, it's 110 degrees. And then I would check this angle to make sure it's 30 degrees. And it is 30 degrees. I would do that for all of E and B as well to make sure that two sides are the same and two of the angles are the same. You will notice, just like our equilateral triangle, they have a line of symmetry. So one line of symmetry, both sides are equal. Okay. The third type of triangle that you will see is what we call a scalene triangle. A scalene triangle has no sides that are the same length. They also do not measure any angles being the same length. You will notice on this scalene that there's two acute and one obtuse. There is no line of symmetry because it will not give the same length of sides. I can check that using my straight edge. So this side is 13 centimeters. This long side is almost 20 centimeters. And this side is 9 centimeters, all different side lengths. I can use my protractor to make sure that each of my angles are different. This obtuse, so it's 130 degrees. This angle right here, if I line up my protractor, it is only 20 degrees. Gonna line up my protractor again on this side, and whoops, got it upside down. This side is 40 degrees. So each one is a different side length. What then is a triangle? A triangle are three segments and three angles that are connected together. They form a triangle. So we see our label is triangle ABC. Here's a point, point, point. There are three segments, and when I connect them together, they will make three angles, and they're not on a line. Remember, this is our line that we learned before. This is not a triangle. It does have three segments, but they're not connected together to form the triangle. So your homework and your problem set are going to be to classify what you see. When you see these little tick marks, those are letting you know that those two sides are the same in length. Okay? So if these two sides are the same in length, this side's longer, that was our isosceles triangle. Two sides that are the same length, one side that is not. B shows tick marks on all three sides. All three sides measure the same. That is a special isosceles triangle, what we call an equilateral triangle. And then this one, looking for that right angle, going back, which one of them had the right angle? Right, an isosceles triangle. And then the last one, it looks a little bit off, like this one could be the same as this, but it's not, and I don't see any tick marks. So that is not an isosceles triangle. It is not an equilateral triangle. It is our scalene triangle, where it has no sides the exact same length. All right, go through each of your problems. Keep going back and looking at what is the definition of each of our triangles. Remember, we have an equilateral triangle, an isosceles triangle, and a scalene triangle. Good luck, Nighthawks.